What we have seen here is you predicted passengers using promotional budget, but that was in isolation. You predicted passengers using inter-metro flight ratio, but that was also an isolated model. Yes, you predicted passengers, but only using inter-metro flight ratio. But do you think, is it only the passengers that impact, is it only the promotional budget that impact the passengers, or it's passengers are actually passengers are impacted by promotional budget, inter-metro flight ratio, service quality score, X4, X5, and so on, XK? Do you think multiple variables impact the target variable Y, or it's only one variable that impacts the target variable Y in isolation? What happens in the real life?
Sir, multiple variables impact.
Multiple variables, their sum total effect put together will impact the target variable Y. Promotional budget along with inter-metro flight ratio, along with service quality score, along with X4, along with X5, X6, and so on, XK, all these variables put together will impact the target variable Y. Until now, we have used a simple regression model, X versus Y. If you have only one X, one Y, that is known as simple regression model. But what if you have X1, X2 versus Y? If you have just X versus Y, then that is a regression line that you have. But if you have X1 variable, if you have another dimension, X2 variable, then your regression will be a plain kind of thing. So that will be Y equal to beta naught plus beta 1 X1 plus beta 2 X2. This is known as multiple regression line equation. What is multiple regression line? If you have variable X1, if you have variable X2, then there will be some points above it, some points below it. You will adjust that. This will be multiple regression line equation. Is it only two variables, or can there be more than two variables that are impacting target variable Y?
Sir,
There can be more than any number of variables can be impacting Y, but only until 3 dimensions we can visualize it. Human eye can perceive only 3 dimensions, but in mathematics you have beta 3 X3 plus beta 4 X4 and so on plus beta k xk. That is the multiple regression line equation where you are using X1, X2, X3 and so on xk variables for the prediction of target variable Y. Tell me, is it simple regression models using one variable that we often build the regression line? Is it multiple regression model that we use in the real life scenarios? When you're working on real projects, is it multiple variables that will impact the target, or it is only single variable that will impact the target?
Multiple variables.
Definitely multiple variables. That's the real world. Real world is multivariate. Your target is dependent on multiple features. These are known as features. These X variables are known as features. Your target depends on multiple features. What is the advantage of using multiple features? Maybe if you are using only one feature, it may not give you good R square value. It may give you 24 or 25 or 30% R square. If you are using multiple features, then there is a high chance that your R square will increase, because these maybe there can be some other powerful predictor features in this list. Or if one variable itself is giving you good R square value of 80%, maybe by adding a couple of more variables, you may get slightly better R square. From 80, you can push it to 85 or 90 or 92 or 93 or 95 or something like that, if considering that you are having some features that are having the impact on the target. So what I'm trying to say is, the real world scenarios, though we have started with simple regression model, that was for our understanding of the concept to visualize what happens. But in real world, you will be building multiple regression model. Is it possible to draw that multi-dimensional regression line? Can we draw it? Is it possible to draw beyond 3 dimensions? No. It's not possible, is it? No. Max to max, only 3 dimensions you can draw, but that does not mean they don't exist. Multiple dimensions do exist. You cannot draw them, but multiple regression line, it does exist. So how do you build a multiple regression line when you're working on Python? How do you give that information to Python? There's only simple change in the code. You use the same code. While you're writing my model, y tilde x was written earlier. Now you'll be writing y tilde x1 plus x2 plus x3 and so on plus xk. It's not a literal summation here. It's a way to tell Python that use x1, x2, x3 and so on xk features for the prediction of target variable y. Consider all these features for the prediction of the target variable y. Okay. In return, Python will give you beta naught, beta 1, beta 2, and so on, beta k coefficient values when you are predicting the target variable y. What is the advantage? Maybe this model will be better than the single predictor or single feature model. Maybe if your model with single feature is already good, maybe if you're adding meaningful variables, it will be slightly better than the previous one. Okay. So go ahead, build this model. Tell me what are your observations from this model. Go back to your code file, build this model, and tell me what are your observations. As soon as you open the output, all of you, as soon as you open the output, where should all our eyes go? The first measure that is most important. Tell me one most important measure in the output window that you look for.
R square.
Yeah.
R square.
What really matters? What is the most important thing? R square value, isn't it? R square decides how good or bad is our model. Very good. All of you. Tell me, what is R square value? Previously, R square used to be 93%. Now that you're adding
95%.
now the R square value has gone to 95%. I'm talking about this model. Look at this. Y tilde x1, x2, x3. Are you talking about this model? Check that, all of you.
Yes.
Yes, sir.
Yeah.
Yes.
So what I'm talking about is a model with 3 features where you are predicting the target variable. From 93, the R square value is 95%. Now look at this carefully, all of you. Come back to this. Another story is starting. Now, imagine you have a data set. In that data set, you have one target variable and you have several features in it. In the beginning itself, you have already cleaned the data. You have features like x1, x2, x3, and so on. X30 features are there. Is it common to have 30 features? Do we have 30 features in your projects?
Yes,
Anybody having 20 to 30 features? All of us have,
Yes, sir.
isn't it? So it's common. It's not a big deal. So you have 30 features. Does that mean all these 30 features should be used in the model? All these 30 features should be impacting the target variable? Is that the case always? Every
Not
variable
always, sir.
that is present in the model has to be impactful. Is there any such rule? Is there any rule that every variable that is present in the model, it has to be very much impactful on the target variable? There is no such rule, isn't it? For example, let me give you an example. You are predicting the risk associated with a customer. Look at this. You are predicting the risk associated with a customer. This is the target variable. You have variable x1, variable x2. Variable x1 name is number of existing loans. Number of existing loans. Customer A has 9 existing loans. Customer B has 1 existing loan. Who is risky?
A.
A is
A.
risky. So is it fair to say variable x1, number of existing loans, is a good impactful feature that should be kept in the model? Is it a good idea if I keep that in the model? It will give me a
Yes,
good
sir.
idea on the risk associated with the customer. That should be kept in the model, isn't it? There's a use of keeping that. It will help me to predict. Yes or no? Do you think number of loans matter? It does matter.
Yes.
Let's say the second variable is customer mobile number. Customer C mobile number starts with 9. Customer D mobile number starts with 8. Customer E mobile number starts with 7. Who is risky? C or D or E?
No one.
No one.
Can we say that?
Not
Using the mobile number, is it a good
Sir,
idea to
cannot be
predict the
predicted.
risk? So do you think, though you have variable x2, are you going to use it in the model building?
No, not impactful.
Is there a
No.
use of keeping it in your model? Is it going to help you to predict the risk associated with the customer?
No.
No, sir.
It's not
No,
going
sir.
to help us. Is it fair to say this variable is not impactful? I can ignore it. Is there any loss that you will face when you ignore such variables?
No, sir.
There's no loss, isn't it? It has no impact on the target. So it is common that you have so many features in the beginning. All of you might have seen. We will clean all the features, whether they are impactful or not impactful. We will not see that in the beginning, isn't it? In the beginning, we treat every variable equally. All of them are important for me. But later on, is there a way I can find out the individual impact of the variables? Whether a variable xi is impacting the target variable or not? Is there any statistical measure that will tell me individually whether the features are impactful or not? Yes, there is a statistical measure called p-value. There's something called p-value. Using some theory, it is calculated. This p-value is calculated for every variable xi. For every variable xi, p-value is calculated. If the p-value is less than 0.05, that feature is impactful. You should keep such feature. If the p-value is greater than or equal to 0.05, that feature is not impactful. You can drop that feature. P-value in the output is given in the place p greater than or equal to modulus of t. In the backend, there is something called t-test that is done. The theory behind that is testing of hypothesis. In our course, at a later point of time, we are going to discuss testing of hypothesis. There, I'll tell you exactly what is the theory behind it, theoretically how p-value is derived. As of now, we will take that theory for granted. We will look at the p-value of the variable directly. P greater than or equal to modulus of t against every variable is given. If that is less than 0.05, that feature is impactful. That is greater than or equal to 0.05, that feature is not impactful. For example, you are using 3 features here: promotional budget, intermetro flight ratio, service quality score. So look at the p-value of promotional budget and tell me. Go to the output window. This is your p-value. Promotional budget P value is how much?
0.
0. Definitely it is less than 0.05. So once again, P value is calculated for every feature. And if the P value is less than 0.05, that feature is impactful. If the P value is greater than or equal to 0.05, this feature is not impactful. As of now, I just want one help from you. You just take this P value for granted for now. The theory behind it, it requires several other measures, several other topics. After discussing those, then exact theory will also be clear at a later point of time. Okay. For now, we will assume that P value is somehow calculated. It will tell you whether the variable is impactful or not impactful. Okay. Now, what is the P value of inter-metro flight ratio? How much is that?
0.350.
0.350, which is greater than 0.05. What is P value of service quality score?
0.
0, which is less than 0.05. So what can you say by looking at the P value? What do you say from
We
there?
can drop
The
inter-metro
flight ratio is not
Inter-metro
impactful
flight
variable.
ratio is not impactful. What do you mean by not impactful? Whether you keep that variable, whether you drop that variable, do you think your R square is going to change? If a variable is not impactful, what does that mean? Whether you keep it or whether you drop it, your model will be indifferent. It does not have it will not lose a lot if you drop that variable. Now, you go to your client and you explain him that inter-metro flight ratio is not impactful. Your client obviously will ask you a question. How can you be so sure? Then what do we say? We looked at the P value. Based on the P value, if the P value is greater than 0.05, P value, based on that, we can say the variable is not impactful. Do you think they are going to believe all these theoretical concepts as it is? Every client wants us to explain in a very layman terms. Yes or no? How do you prove to a layman that inter-metro flight ratio is not at all impactful? Think about it. How do you prove to a layman who doesn't want to believe P value? How do you prove it that really, seriously, inter-metro flight ratio is seriously not impactful? How do you prove that?
Get another model.
So right now you built a model y versus x1, x2, x3. What is R square of this model? What is R square of this model?
95%.
95%. Now, if x2 is not impactful, that's what I want to prove. If it is truly not impactful, what will happen? Tell me. How can you prove that? You build another model.
By dropping
y
that
versus
column.
x1, x3. If it is truly not impactful, what is the expected R square?
95% around.
Almost 94.9% or 94.8. Almost same R square should be there. Yes or no? Not a significant drop. Do you agree with that?
Yes, sir.
Yeah. A small difference is fine, but it should not be like dropping from 95 to 90 or 95 to 80. That should not happen. Almost same R square should be there. So do that experiment and tell me what is the R square value if you are using only promotional budget and service quality score, only those two variables.
0.951.
How much?
0.9. So 95.1.
Again, 95%. With that variable, your R square is 95%. Without that variable, your R square is 95%. Isn't that a proof that that variable doesn't matter? Do you want to keep it in the model or eventually you want to get rid of that? What is the better option?
Get rid of it.
If a variable is not impactful, is it a good idea to keep it in the model? Imagine model M1, which is using 30 features, giving you 92% R square. Model M2 using 10 features which are impactful, 20 features which are not impactful or dropped. It is giving you 91% R square. Which model would you keep?
Sir, M2.
M2 is much simpler model, which is also giving you almost same as M1 R square. We would generally, business requires simple models that are working as effectively as those models that are complex, but using lesser number of features. That is how you will check the individual impact of the features. Once again, the exact theory behind the p-value is not yet explained to you. There is another concept which is called testing of hypothesis topic. Once that is explained, then that will be clear to you. Okay, the theory part of it. But as of now, we are taking the application part of that. I think that was one of the questions, right? Somebody asked, like, how do you know in the list of variables that I have whether a variable is impactful or not? How do I get to know that? You can see the p-value and you can select a variable that is impactful. Now, when you see the output, there's one measure called adjusted R square. All of you, have you observed it already?
Yes.
Yes, sir.
Adjusted R square is given. A lot of times in the real world, people are not using adjusted R square, but there is a particular use of adjusted R square that you will find it very, very helpful. Let me explain you the concept of adjusted R square using a simple example. This is a small simulated data It's not a real data set. Just to explain the concept of adjusted R square, I have created it. In this data set, what you need to do is you have to import this data, build model M1, which is trying to predict target variable Y using 3 variables. That is model M1. For that model, look at the value of R square, look at the value of adjusted R square. Build model M2, which is Y versus X1, X2, and so on, X6 variables. Look at R square, look at adjusted R square. Model M3, Y versus X1, X2, and so on, 8 variables. What is R square? What is adjusted R square? So tell me these values for model M1, M2, M3. What are the values of R square, adjusted R square? Give them to me in the chat window. M1, R square, adjusted R square. M2, M3. Give them to me. Then I'll explain you what is the concept of adjusted R square. Give the numbers to me in the chat window. M1, R square, adjusted, M2, M3. M2, R square is 71%. Adjusted R square is 37%. Last model, R square is 80%. Adjusted R square is 28%. Are these the same results that you're also getting?
Yes, sir.
As you can see, if the variables are increasing 3 to 6 to 8, what's happening to R square? It kept on increasing. But adjusted R square did not do that. It decreased first, again it decreased. Now the concept of R square, the formula of R square is most widely used and it works at most of the places. But if you look at the exact formula of R square, it has one caveat. R square formula has one issue. And particularly in some projects, R square will actually give you a wrong answer. Let me give you an example. Let's say you're building a model, Y versus X1, X2, and so on, X10 variables are there. With these 10 variables, R square value, you have achieved it to be 80%. Okay. When you add the 11th variable to the system, you have 10, you added another extra variable, 11th variable. There can be 3 scenarios that are possible. The first scenario is the variable is very much impacting on Y. It's a very powerful impactor. The variable has so much information about Y. The variable has very good information about Y. Then what will happen to the R square value?
Sir, it will increase.
It will increase significantly, a very good amount, isn't it? 3 points, 4 points. One variable itself will increase 3, 4, or 5 points. That is one scenario. The other scenario is if the variable is not at all impactful, if the variable is junk variable, if the variable has nothing to do with the target. One of the examples is risk versus mobile number. A variable has nothing to do with the target variable Y. In that scenario, either R square will remain the same because you already have 10, right? With that 10 anyway, you will get 80. Either R square will remain the same or R square will increase insignificantly. There was an increment, but insignificant, very minuscule. But what will never happen is if you add a junk variable, if you add a variable that is having no impact on the target, R square will never go down. This will never happen. With an addition of new variable to the existing system, R square will never go down. Why it will never go down? Already you have 10 variables. With that 10, how much is guaranteed?
80%.
80%. If you are bringing a new variable, either that variable will bring extra information or It will not.
No information.
No information. That means it will not bring any negative, or there is no way that predictive power of these variables will reduce. That will not happen. Okay. So bringing a new variable will never reduce the value of R square. Now that can be a problem sometimes. Most often from my experience, what I can say is if you add a junk variable to the system, most often it will increase insignificantly. This is what you're going to see most often. After observing it, I kept on adding several variables. 200 such variables I have added. X11, X12, X13, and so on, X200. What will happen? 80.01, 80.02, and so on. One day R square will be 100%. Does that mean this model is exactly 100% accurate model? Whatever the prediction it is giving, exactly the same values you will get? Or are we simply cheating the formula of R square, somehow making it look like 100% R square? But what is the original R square? What is the original prediction accuracy of this model?
80%.
Original prediction accuracy of this model is 80%, but somehow we kind of cheated the formula of R square, make it look like 100%. That is the problem with R square. If you add too many features, if you add too many non-impactful features, what will happen? R square will look like almost very high value near to 100, but that's not reflecting the original accuracy, original predictive power of the model. That's why there is a small adjustment that has been done to the R square formula. It will now come as adjusted R square. Adjusted R square is derived from where? Is it a totally different formula? No, it is derived from, adjusted R square is derived from R square only, but there is a penalty factor that has been included. What it will do? When you add a new feature, adjusted R square can also increase. When it will increase? If the feature is impactful. If the feature is junk feature, still you added it, then what this penalty factor will do? Can you make a guess? Adjusted R square will actually, if you add a new feature, if it is junk feature, then adjusted R square will actually go
Decrease.
down, decrease. The decrease factor, this is that penalty factor. If you're adding a new feature, adjusted R square will actually decrease if the feature is not. Is it true that adjusted R square will always decrease when you are adding a new feature?
No, sir.
When it will increase, adjusted R square will also increase. When
The variable is impactful.
When the feature is impactful, then it will increase. So how do you use adjusted R square in the real life projects, in real life scenarios? How do you use that? As soon as you build the model, what is the first thing that you check? As soon as you build the model, you check the R square. Go ahead, check the R square as usual regularly. Let's say R square value of the model is 92%. Now that after knowing this concept, do you think we should trust R square directly on the face of it?
No, sir.
No. Immediately after checking R square, from here on, what you should check?
Adjusted R square.
Adjusted
R square. Let's say if adjusted R square is only 72%, R square is 92, adjusted R square is 72. What does that mean?
The variable is not impactful.
There are several variables that are still present in the model, but they are not impactful. If they would have been impactful, if everything would have been impactful, what would have been the adjusted R square value?
Sir, near to 92%.
Near to 92, maybe something
Nearly.
like 92 or 91. 1 or 2% difference is okay. In the real life, you can accept this. This and this you can accept. But can you accept 72 and 92?
No,
That
sir.
you cannot. Is it a negligible difference or a significant difference?
Significant, sir.
Significant difference. 1 or 2% is generally known as negligible difference. That happens. But 20 points is a significant difference. That means there are some variables that are not impactful. By the way, is there any measure that will tell you, given a feature, whether it is impactful or not? Can you tell me that? Which measure will tell you whether a variable is impactful or not? How do you get to know that?
P-value.
You will look at the p-value. Based on the p-value, how do you pick and choose that variable, whether it is impactful or not?
Sir, less than 0.05 is
Less than
impactful.
That is
0.0.
impactful. 0.05, that variable is not impactful. But what happens in the real life scenarios is, the reason why a lot of people don't care about adjusted R square is, most often your R square will be almost equal to adjusted R square. In every project that you do, you tend to see that your R square is equal to adjusted R square. Here somehow I simulated this data to make it very wide like this. But in most of the projects, your R square will be equal to adjusted R square. Only there will be a huge gap between R square and adjusted R square when there are too many unimpactful features. Too many non-impactful features are there in your model. Too many of them. That means more than 30 features are there in your model which are not impactful. Then you may start seeing R square, adjusted R square very far away. Otherwise, there'll be almost same 1 or 2% difference. That should be fine. In most of the cases, R square, adjusted R square will be same. That's why people don't pay attention to this. But what is the specific use of adjusted R square? What happens to adjusted R square when you have too many features that are not impactful? Then what happens to the R square, adjusted R square? Adjusted R square will be much lesser than R square. So the question that comes to you generally is, How do you interpret adjusted R square? What is the use of it? So one of the scenario is R square is 92%, adjusted R square is 72%. What does this tell you as a data scientist? What do you understand from here? That's the only question that you will get. What does that tell you?
There are lots of
There are so
unimpactful
many
variables.
features that are not impactful. Can we finalize this model, or we have to go back and check for impactfulness of the features, only select those features that are impactful, keep them in the model? Can we finalize this, or can we have to go back?
Sir, we have to go back.
We have to go back and check only the features that are impactful, only keep them, and drop the features that are not impactful. Are you with me, everyone? Have you understood the use of adjusted R square? It's like an internal measure. Finally, R square is the only measure that is reported. Finally, R square is the only measure that the whole world follows. But before finalizing R square, what do we make sure? We make sure that for our model, R square and adjusted R square are almost same. That we will make sure. Then you can use either R square or adjusted R square. Clear, everyone? Let's pause here, take some questions before we move on to the next subtopic within regression. Now, let us take a different case study altogether and then try to see some other complications that may come. Now we are going to work with regional sales data. We are trying to predict what is the sales in the region by using features like what is the average income in that region, what is the average given average income, average expenses, percentage male, percentage female in a region. I want to find out what is the sales in that region. I want to predict this. This is target X1, X2, X3, X4 features are there. What I want you to do is import this data set, go back to your code file, regional sales data. Yeah, after adjusted R square, regional sales data, and then import this data set, have a look at the columns quickly, and then build the model. Only execute until here, build the model. Once you have the output ready, we'll discuss about this output. Right? Are you ready with this output?
Yes.
Right? Tell me, what is the first thing that you check? As soon as I go to this output, what is the first thing that we will be checking?
R square.
R square.
Automatically, as a data scientist, our eyes should be going on directly onto R square. And what is the check that we will do? R square must be
More than 8.
More than
More than
80%.
More than 80%.
so first check is passed. Fine. Going good. Sometimes this may deceive you. R square value may cheat you. That is why, to be on the safe side, immediately after checking R square, it is suggested that you check the value of
Adjusted R square.
adjusted R square. And what should be the value of adjusted R square for a good model?
Near
Sir,
to
near to R
Near
square.
to R square. Exactly, precisely same as R square, or 1 or 2% difference is okay.
Sir, 1 or
Negligible.
2%
Percent
difference.
difference is okay. So is adjusted R square same as R square
Yes, sir.
here? Yeah, 84.5 versus 83.8. You cannot, like, in reality, you cannot expect exact precise same values. So this is also passed. After passing these two, what is the next thing that you're going to check?
P-value.
P-value.
Good, very good. We are going in the right direction. Go ahead. Based on the p-value, what are you going to tell?
Whether the variable is impactful
Impactful
or
or
not.
not? Yeah, tell me, is there any variable that is not impactful?
average expenses.
Sir,
Average
almost all the variables.
or not impactful? This one is less than 0.05. This is impactful. Anyway,
Average expenses is not impacted.
yes or no? This is impactful. This is impactful. This is the only variable that is not impactful. Are you with me? What is the limit? Once again, tell me. What is the limit?
Less than 0.05.
0.05, right? This is the only variable that is having more than 0.05. Yes or no? Remaining all are impactful. This is the variable. Average expenses is the variable that is not impactful. In fact, you can also see the sign and tell whether it is having a positive impact or negative impact. Average income has a positive impact on target. Average expenses has negative. Percentage male, positive. Percentage female, positive. So from this output, what we can say is, when you are predicting the regional sales, are you getting a good model by using income, expenses, male, female? Is that a good model? Overall, we are getting a good model because we know that 80% above is the R square. Second point that we note down is average expenses is
Not impactful. Not impactful.
impactful. Very good. Third point that we can note down is if at all there is any impact, average expenses is happens to be having a
Negative.
negative impact. Now we go to our business partner. We tell our business partner, you know what? I can predict the regional sales easily. You give me income, expenses, percentage male, percentage female in that region. I can give you a model. I can give you a prediction how much will be our sales, and I'm very confident about it. And I also did some analysis. I found that average expenses has no impact. We can drop it, or even if you keep it, it has a negative impact. Like as average expenses increase, the impact on the target, like the target variable, which is sales, it will decrease. That's what we told. And the client is responding to you. I'm your client. I'm giving you the feedback. Your first point, I agree. You can predict the sales. In fact, these are the factors that will drive the sales. So I agree that if I give you income, expenses, percentage male, percentage female, you can predict sales. I agree. Very good. Your second point and third point are utterly wrong. They don't make any business sense to me. Average expenses is the most impactful variable on sales in my experience. That's what I have seen. I have been in this industry from past 30, 40 years. Average expenses is the most impactful variable based on my business knowledge. I can tell you that. I don't know what your data analysis is saying. And how can you say average expenses has a negative impact on sales? Are you trying to tell me if average expenses is high, if everybody is spending in a region, what are you telling me? Our sales are going down? Are you trying to tell me if the average expenses is low, if nobody is spending, what are you telling me? Our sales is going up? That doesn't make any sense to me. Do you also agree with the client points?
Yes, sir.
Yes,
You also feel that expenses and sales should be directly related, isn't it?
Yes, sir.
How can our sales increase if nobody is spending? Yes, I to bata raha hai. The client is true. Something would have gone wrong. We have to investigate. These kind of results, counterintuitive results, may be the result of not doing the data cleaning properly. Yes or no? If you do not do the outlier treatment properly, if you do not do the data cleaning properly, then this may happen. Is it possible?
Yes, sir.
Yeah. So I'll go back to my data cleaning step. I check everything. So I have done my due diligence. That means all of us, before doing any analysis, what is our thumb rule? Are we going to get the raw data and do the analysis? What is our thumb rule?
We have to clean the data.
Never ever start the analysis without cleaning the data. So we will clean the data. So as usual, we followed, like we are all good data scientists. May not be advanced, experienced, or expert data scientists, but we know our basics well. We clean the data. We come here, right? So data cleaning was done. Something we are still missing. Beyond data cleaning, there must be something else. Client is saying that average expense should be there in the model. So as an experiment, what we can do is, just as an experiment, as of now, keep average expenses. Maybe drop average income. Just as a random experiment, we are doing this because as part of investigation, we are trying several things. This is one of the trail. Drop average income, keep average expenses, percentage male, percentage female. Use three variables: average expenses, percentage male, percentage female, to rebuild the model. Go back, rebuild the model with these three variables, keeping this, dropping that. Once you have the output with you, then we will discuss that.
Now the p-value is 0.
First things first.
No, sir.
What is the
R
first thing that
value
we
is
take in the output?
83%, sir.
R square.
R square value is
R square
83%.
value is 83.8. Is it almost same as the previous R square, or is it significantly dropping?
Sir, almost same.
It's almost same, sir.
Almost same. No need to panic here, isn't it? From the model prediction point of view, this is not a very poor model. Can I say this is very poor model? This is very good model?
No, sir.
No. What about adjusted R square?
Almost same, sir.
83.2.
Almost same. No
Almost
difference
same.
at the overall model level. Can I make that statement?
Yes, sir.
Yes,
Yeah.
sir.
1 or 2% difference that happens in the practical life. Yes or no? Yeah.
Yes, sir.
So that is fine. Why this 1 or 2% difference happens? Because you might have seen the variables when you're doing the data cleaning. We assume, right? The perfect box plot was not there. Perfect things were not happening. Because of that issue, there can be 1 or 2% difference here. But where is that monumental change that you have observed? Where is that huge difference that you have observed? Not at the R square level. Where did we observe?
P-value.
P value, if you look at the average expenses P value, now it is less than 0.05. That means average expenses is impactful. What else have we observed? Average expenses has now
Positively impacting.
positively impacting. So I have built a model 2. Yesterday in the client meeting, client told that these two are utterly wrong points. Now today I have another meeting with the client. I have built model M2. Previously, yesterday model was M1. Today's model is M2. I'm saying that I can still predict sales with the same confidence. Yes or no? Can we
Yes, sir.
predict sales with same confidence? Yes. Second thing is, now I'm saying average expenses is now, earlier I told
Positively
not
impacting.
impactful. Now I will say impactful. Also it is, average expenses is
Positively impacting.
positively impacting. What's happening? Model M1, model M2. Tell me one thing. Did you go back to the data set? Did you change any values in average expenses column?
No,
आपने
sir.
कुछ change किया क्या? Did you change any data points in average expenses? Or have you used precisely the same data points in average expenses in model M1 and model M2? Tell me.
So same data points.
Same data point. How can you use the same data points? Sometimes you're saying average expenses is negatively impacting. Sorry, average expenses is positively impacting. Isn't that contradictory? Can we go to our client and agree with him? Do you think he's going to believe us? Using our data analysis, once I'm saying it is negatively impacting. Now I'm saying it is positively impacting. Yes, we are agreeing with him. But do you think he's going to continue this model? There's something that's grossly going wrong in the back end, isn't it? We need to be careful with that. Usually, this kind of situation, you will fall into this kind of situation when there is interdependency between these features. When these two features are interdependent on each other, then you cannot really trust the beta coefficients. What do you mean by interdependency? Average income in a region and average expenses in a region are connected to each other. For a family, if income is high, expenses will be automatically high. For a family, if the income is low, expenses, they have to be low. Is that a right statement? Do you believe that income and expenses are very much related to each other, or they don't relate to each other at all?
Sir, very much related to each other.
Very much related to each other. In fact, for the most of the portfolio, if income is X dollars, people tend to spend around 65% of their X dollars. Do you believe in that? We tend to spend a portion of whatever we earn. We don't really take loan from everywhere and try to spend, isn't it? Expenses are very much related to income. Which means if I give you either X or 0.65 into X, does that really matter? From the model point of view, are these really two different dimensions of information the model is getting, or it's just one dimensional information expressed in two different columns? Tell me. Though it is income and expenses, is the model getting any additional information from an extra variable called expenses?
No.
No, sir.
If I give you income, can you guess expenses? Yes. Another example is, for example, you have income in dollars. That is one variable that you have. Another variable is income in rupees. Tell me honestly, this is variable x1, variable x2. Do you think variable x1 and x2 carry totally different information, or x2
Sir,
is simply
same information.
same
With
information?
different
If
currency.
x1 is x, let's say if x1 is $10, do you really require the data points to tell you what is x2, or you can guess it anyway?
So we can guess it.
We can simply guess it. Whatever is the income in rupees, that will be some 70 or 75 or 80, whatever, into $10. So you have these two variables. Is it fair to say these two are interconnected, interdependent variables? Percentage male in a region, percentage female in a region. If in a region percentage male is 50%, roughly what will be percentage of female? Roughly
50%.
50. If the percentage of male is 55%, roughly what will be percentage of female?
45.
45. If this is X%, roughly what will be female?
100
minus
minus
X. Is it fair to say percentage male, percentage female, they don't carry two different dimensions of information? It is pretty much same information, but it is expressed in 2 units. Yes or no? This
Yes,
type
sir.
of variables which are interdependent, when the variables are interdependent, you cannot really trust the coefficients. That phenomenon is known as multicollinearity. What is multicollinearity? Interdependency between the features is known as multicollinearity. Two or more variables giving the same information is known as multicollinearity. Duplication of information is known as multicollinearity. Redundancy of the information, carbon copy of information, two or more variables related to each other is known as multicollinearity. Let's say when you are building a model, y versus x1, x2, and so on, xk. Sometimes x1 is related to x2, sometimes x1 is related to x9, x1 is related to x3, x25, x36. X1 is related to X4 and X13. Any variable multicollinear, or sometimes X5 is related to X19, X23. Interdependency between the features is known as multicollinearity. Let me prove once again why multicollinearity is an issue. What is the problem that it causes? For example, you're building a model. You finally found that y equal to x1 plus 2x2 minus x3. That's the model that I got. Yes, there was multicollinearity. X1 was 2 times X3, but I don't care. What's the problem here? Model aa gaya. I have the model. I don't care. I have got the model. What is the issue? I don't see any issue here. Now tell me that can be rewritten as y is x1 plus 2x2 plus x3 minus 2x3. Look at that. Tell me equation 1 and equation 3. Are they one and the same? Equation 1 and 3?
Yes, sir.
Because minus x3 has been rewritten as plus x3 minus 2x3. Both are one and the same. There's no difference, right? Now tell me, can I rewrite that as y equal to x1 plus 2x2 plus x3? In the place of minus 2x3, I can substitute
X1.
minus x1. Yes or no? From which equation I can substitute that?
2.
Second equation.
That will be y equal to this x1, y equal to 2x2 plus x3, which is equation 5, derived from 4, derived from 3, derived from 1. Equation 1 and 5 are essentially same equations. Equation 1 and 5 are one and the same. There is no difference between them. But if I go to equation 1, if I ask you the relationship between x3 versus y, is it a positive relation or is it a negative relation? According to 1, this equation, the relation between x3 versus y, that is a negative relation. If I come here and ask you the question, the relationship between x3 versus y, is that a positive relation or a negative relation according to 5th
Positive.
equation?
Positive relation.
Positive.
If I come here, if I ask you the relationship between x1 versus y, is that a positive relation or a negative relation between x1
Positive.
and y?
Positive.
If I come here and if I ask you x1 versus y, is that a positive or a negative relation?
And no relation here.
There is no x1 at all, which means no relation. Sometimes I'm saying negative. No, sorry, positive. Sometimes I'm saying positive. No, sorry, no relation. Don't you think these are all contradictory results that I'm giving? Can you tell me what is the cause of all this contradiction? Which equation is causing all these contradictions?
Second.
So
First equation or the second equation? This is the one, right? If I could not express x1 as 2 times x3, then it'll be no such issues, isn't it? This is the equation that is causing all the contradictions here. X1 is 2 times x3, x1 and x3 are related to each other. What is this known as? The interdependency between the features. This is known as
multicollinearity.
Multicollinearity. One of the most widely asked interview question. Any data science interview that you go, one question will be common in them. What is multicollinearity? So let's explain what is multicollinearity. Interdependency between the features is known as multicollinearity. Redundancy of information, 2 or more features giving the same information is known as multicollinearity. Carbon copy of information between the variables, relationship between the variables is known as multicollinearity. Can you explain what is multicollinearity to a layman now? Interdependency between the features.
Yes, sir.
Yeah. Now let us see how do you detect multicollinearity, because in our data set it can be so many variables can be there, right? There can be 40, 50, 60, 100 variables are also possible. Is it possible to have 100 variables in a data set and we are building a model on that? Possible.
Right.
So how do you detect multicollinearity? Here is the process. When you are detecting multicollinearity, you can forget about the target variable. Why? Why can you simply ignore target variable when you are detecting multicollinearity? Because multicollinearity is something that is related to only features.
The dependent variables.
Features, isn't it? Dependent or x variables. These are called independent variables. These are not dependent. That's an easy way to look at it is features. You can call them as features. Okay. Now take x1. Try to use x2, x3, and so on, xk. Try to build a regression model. Try to predict x1 using all the other variables. Let's call that as regression model 1. You're trying to predict x1 using rest all variables. Calculate the R-square value. R-square value of that model, okay, comes out to be, let's say, 95%. Let me call that as R1 square, because I should not confuse that with original R-square of the model. If R1 square is 95%, that is x1 versus rest all. What does that mean? What does that mean? You can very well predict x1 using rest all variables. Yes or no? All the variables have the power to predict x1. Is it fair to say x1 carries no independent information? Everything A can be seen in the rest of the variables. Isn't it a clear indication of multicollinearity? Yes or no? Multicollinearity is definitely present. In some other scenario, you build the same model, you got the R square value to be, let's say, 5% only. For the same model, you got the R square value to be 5% in some other scenario when you did X1 versus rest all. What does this mean?
Sir, there is no multicollinearity.
There is no multicollinearity with respect to X1 variable. You repeat the same X2 versus X1, X3, and so on, Xk. Calculate R2 square. Check whether it is higher or lower. Repeat the same with Rk versus X1, X2, and so on. Rk minus 1, Rk square. So any individual variables Xi versus all the other variable Ri square. If that Ri square is high, that means there is multicollinearity with respect to that variable. So that Ri square, we do not directly use it. We derive one more measure out of it, which is known as VIF. VIF is equal to 1 by 1 minus Ri square. That means if that Ri square increases from 0.5 to 0.75 to 0.8 is serious, isn't it? Do you think 0.8 Ri square you got? Can we consider that as a serious case?
Yes, sir.
Yeah. So what is VIF? 1 by 1 minus 1 by 2. VIF will be 2 in this case. 1 by 1 minus 3 by 4. VIF will be 4 in this case. 1 by, this is the place where we get really serious. 1 by 1 minus 4 by 5. 1 by 1 by 5 VIF will be 5. So if VIF of any variable, if it is greater than or equal to 5, that is a clear indication. Like indirectly what it means, that variable versus rest all variables, Ri square is greater than 80%. It clearly indicates that that variable is involved in multicollinearity for sure. Okay. That is how you detect multicollinearity. Once again, let us recap this whole thing. Usually it is target versus rest all, but target we ignore it for some time because I want to check multicollinearity. Okay. Take the first variable, use rest all variables, calculate R square. Take the second variable, use rest all, like that, repeat for every variable. For everything, take the Ri square. If that Ri square value increases from 40 to 50 to 60 to 70, VIF stands for variance inflation factor. Variance inflation factor. Generally, people use it as VIF. VIF is 1 by 1 minus Ri square. If Ri square is above 80%, VIF is more than 5. If the VIF of a variable Xi, if it is more than 5, clearly it is involved in multicollinearity for sure. There's no doubt about it. Got it? So how do you detect multicollinearity? What is the measure that is used for detection of multicollinearity? Which measure is used?
VIF.
VIF. And how do you choose which variable has multicollinearity issue? If VIF is more than 5.
More than 5.
If you go back to our case study, in our case study, we have average income, average expenses, we have percentage male, percentage female. In general, you can have multiple other variables as well, isn't it? So you have to take every variable, take rest all variables and calculate the VIF value. Okay. So for that, we can write a function. This function simply, what does it do? It takes all the variables. Okay. Chooses, it runs a loop. We have to run a loop, isn't it? Take one variable first, like when I equal to 0 or when I equal to 1, I'll take the first variable. Then Y variable will be X1. X variable will be what? X2, X3, X4. Then calculate the R square 1 by 1 minus R square VIF will be printed. Repeat the same for rest all variables. So this is the function that will calculate the VIF for each and every variable. Okay. Use this function, and if the VIF value, once again, if it is greater than or equal to 5, that is the variable that is involved in multicollinearity. So let us calculate the VIF value of each and every variable and give those numbers in the chat window. VIF values, give them to me in the chat window. Average income has a VIF of 863. Average expenses has a VIF of 862. Percentage male has a VIF of 11.31. Percentage female has a VIF of 11.48. Once again, tell me, when do you say the variable is involved in multicollinearity?
Sir, when it is greater than 5.
5. Is it greater than 5? Of course, yes. Is this? Of course, yes. Is this? All the 4 variables have more than 5 VIF, which means we drop all 4 variables. What the hell? Are we really going to drop all the 4 variables? There is a small twist in this tale. Look at this. All of you focus on this. Y versus x1, x2, x3 is your model. Okay. Let us suppose x1 is 2 times x2. There is a kind of multicollinearity existing. When you're calculating VIF of x1, which is x1 versus x2, x3 model, what will be the value? Will it be more than 5 or less than 5 for VIF of x1?
More than 5.
It will be more than 5. When you're calculating VIF of x2, which will be x2 versus x1, x3, will it be more than 5 or less than 5?
More than 5.
Because it is x2 versus x1, right? This can be rewritten as x2 equal to 0.5 times x2. So this will be more. Imagine x1 is income in dollars. Imagine x2 is income in rupees. Income in dollars will also have VIF more than 5. Rupees will also have VIF more than 5. Does that mean I drop both dollars and rupees, both of them?
Sir, one of them.
Any one of them I have to drop. If I drop both of them, I lose the information on the income dimension altogether. Yes or no? When you are working with VIF, the variables that are related anyway, both of them will come VIF more than 5. You have to drop the most redundant one. Most redundant one. The one that is the most redundant, that's what you have to drop. The variable that is most redundant. That means the variable that has the highest VIF, that you need to be dropped first. Automatically the other variables will get corrected. Short of these, am I going to drop all the 4 variables?
No.
No. Which variable am I
First
going to
one.
drop now?
Average income.
First one.
This one will be dropped. Are we dropping it because this is variable x1?
No. Highest VIF.
Oh,
The
highest.
variable that has the highest VIF. That will leave you with 3 features. Can I assume that anyway 3 features are there? Definitely these 3 features will be definitely independent among themselves. Can I think of that?
No, sir.
Or do we need to check VIF once again within this system of these 3 features?
By dropping the average income.
Do we need to check or can I keep all these 3?
Sir, we have to
All
check.
these 3.
So recheck by dropping average income. Now you have 3 features. What are the updated values of VIF? What are the updated values of VIF?
One 1.0.
1.07,
11.29,
7.29.
11.41.
This did not change much. This did not change much, but this one, huge difference. Why? Why suddenly average expenses has a very low VIF?
Because sir, the independent variable of this feature has been removed.
Previously, there used to be some kind of relationship. Now that it has been removed, this is carrying some independent information that you cannot find in percentage male, percentage female. Does that mean the system is totally having all independent features, or still there is multicollinearity left here?
Sir, there is multicollinearity.
So which variable are you going to drop now?
The female.
Percentage.
The variable that has the
Highest.
highest
Highest
VIF.
collinearity.
That will leave you with 2 features. If there are 2 features, is there always a guarantee that those 2 have to be definitely independent, or do we need to check that? We cannot assume anything, isn't it? Go ahead, check that. Tell me what are the updated values of VIF.
1.01.
Sir, 1 and 1.
1.01.
Is it fair to say you do not need 4 features? 2 features are sufficient. They are carrying the 4 features information. Is it fair statement? 2 features are sufficient, isn't it?
Yes, sir.
Average expenses is carrying the information of average income. Percentage male automatically carrying the information of percentage female. So you don't need 4 features. 2 features are sufficient. Now these 2 are independent features. Independent. Does that mean both the features will be impactful on Y? This will be impactful on Y. This will be impactful on Y. Can I give the guarantee based on VIF? Does VIF tell us anything about the impact?
No.
No, sir.
No, sir.
What will tell you about the impact? It's not VIF.
P-value.
What will tell
P
you?
value, sir.
That is a different story altogether. P value. Can you give guarantee that this has to end up impactfully? Can you give guarantee that this has to end up impactfully since they are independent? No. P value tells us whether a feature is impactful or not. All of you, once again, the clarity is P value. What does it tell you? X versus
Y.
Y. VIF. What does it tell you? X versus
X1.
X versus X only. Yes or no? Whether these 2 are like this, you can call that as XI versus XJ. This is XI versus Y. So is it possible that out of these 2, we may end up with only 1 variable? Is that also possible?
Possible.
Possible.
Yes, sir.
isn't it? So impact is a different story altogether. Independence is a different story altogether. All the variables in your final model have to be impactful as well as independent. Impactful means every variable has to be impactful on Y. Independent means every variable has to carry independent information. Those are the checks that we need to take care of. That is why while you are building the regression model, you have to follow these steps, step by step approach. But even before building the model, what is even the previous phase? Before building the model, what are you going to do? You will make sure that data cleaning. Even before data cleaning, what is the step?
Exploration.
Even before exploration, what is the step? Before even the data, you start understanding what is the business problem, goal, and all that. Okay. First, get the business idea, objective, and all that. Then data exploration, data validation, data cleaning. Then comes the model building. Which phase is this? Model building phase. If you remember that flow chart, which phase is this? Phase 1 was business problem, objective. Phase 2 was data exploration, validation. Phase 3 was data cleaning. This is 4th phase. Okay. Can we directly jump on to 4th phase in any of the projects?
No, sir.
There is no project in this world that you can go on to the 4th phase directly. So these are the steps in model building. First step is build the regression model. While building the first model, try to use all the features. Okay. Try to use all features. Don't pick and choose any of the features in the beginning itself. Anyway, we will choose the features later on. Okay. Immediately after building the model, what would you do? Immediately after building the model,
Check for R square.
R and adjust
R square. What should be the R square value for a good model?
Greater than 80%.
80%.
For a good model, R square should be above 81. Imagine your model is having good R square. What is the next thing that you're going to check?
Adjusted R square.
Because sometimes R square will cheat you, isn't it? That's why you check the adjusted R square. And what should be the value of adjusted R square for a good model?
Near to R square.
Near to R square.
Near to R square. Almost same. 1 or 2% difference is fine. After that, what is the next step?
P value.
Check
The p value. What does p value tell you? What is the use of checking the p value?
The impactfulness of the feature.
Whether
Impactful,
the
not
feature is impactful or not impactful. Tell me, how do you choose?
Less than 0.05
Then
is impactful.
0.05 is impactful.
That feature is impactful. Keep or drop?
So keep.
Such features. Greater than or equal to 0.05, that feature is
Less impactful.
Not impact. Less.
not impactful. Is it okay to drop? Or are you going to lose anything if you drop?
Drop.
No, sir, we will not drop.
We will drop. What is the need if there's a variable that is not impactful? Okay. The next one. Once you're done with this, you have all the features that are impactful. What is the next thing that you'll do?
BIF.
Check the VIF values. Based on VIF, how do you pick and choose?
Less than.
VIF less than 5,
Yes.
that feature is
Impactful.
Independent.
Depend. More than 5
independent.
is independent.
Independent. What do you mean by independent? It carries independent information. Less than 5 means what? Independent. It has no connection to the other variables. In that case, are you going to keep or drop?
Keep.
Keep. It carries independent information. Greater than or equal to 5, that feature is
Dependent.
dependent on others. Then what I should do?
Drop.
Drop.
But while dropping, you need to be careful.
1 by 1.
You have to drop sequentially, one by one. Is that true?
Yes, sir.
When I was doing this training, one of the corporate training in one of big company, they're already working on all these steps. So what they were doing, they have a situation Y versus X1, X2, and so on, some 30 variables they are using. Out of these 30 variables, they're calculating the VIF value. It's a very renowned company. So they are calculating VIF values for 24 variables. VIF is less than 5. For 6 variables, VIF is greater than or equal to 5. They're dropping these 6 variables and they are using these 24 variables. Can you tell me what is the error in that process?
Sir, we might lose some important information.
If 6 variables are having VIF more than 5, does that mean all 6 should be dropped?
No, sir.
we have to check one by one.
One by one, isn't it? Will you be doing that error? For some reason, even a lot of projects, some people are making this mistake directly within one shot. They are dropping all the variables. Make a side note here. Make sure that you're doing sequentially. At the end of this, you have all the variables that are independent of each other. Another point is there's no order that you have to follow like this. Sometimes you choose all the independent features. Then out of them, you can choose impactful features. Or sometimes you can choose impactful features. Then out of them, you can choose independent. Whether you follow step 4 first or step 5 first, it doesn't matter. Okay. You will get the same result in the sense you will have the same R square. So the order of step 4, step 5 doesn't matter. Okay. Only thing is that you have to make sure that you're doing those 2 steps for sure. So these are the steps that you must follow when you're building a regression model. In fact, in some of the interviews in the past, some of the recruiters asked this question: how do you build a regression model, what process you follow. So some of our students have explained all these steps one by one, one by one, one by one. Those interviews went very well. Will you be able to explain all these steps to the recruiter? Have you understood all these steps? If somebody stops you at VIF and asks you what VIF does, why are you doing it? Can you explain it? If somebody stops you at p-value, somebody stops you at r-square, will you be able to tell that to a layman? Have you
Yes.
understood the concepts behind these? Yeah.
Yes.
So that is the story of regression.